on to question 6. We're given a trigonometric identity that we're asked to prove. Now, trigonometric identities, the way you work with them when you're asked to prove them is that you have to pick a side. You pick either left-hand side or the right-hand side. The side you pick is usually not specified because we want to give you that freedom, and it doesn't actually matter. But as a rule of thumb, always try and pick the side that looks more complicated. By that I mean there's something you can do, or you can see, oh, okay, maybe I should multiply out the brackets here. Maybe I should add these terms. I should do something. Instead of picking the side that looks simple and you have to try and figure out how to complicate it, okay, or how to make it bigger or longer so that it looks like the other side. Okay, I hope that makes sense. So pick the side that looks like there is work to be done on that side, then it's easier. And another rule of thumb is, with this one we won't use it, but if you have other trigonometric ratios, instead of sine and cos, if you are stuck, convert them into sine and cos. Sine and cos are the simplest trigonometric ratios, and all the other ratios can be written in terms of sine and cos. Okay, so first thing you do, pick a side, whichever looks complicated, work on that. And if you're stuck in the other trigonometric ratios, let's say tan, cosec, cot, whatever, simplify them, rewrite them in terms of sine and cos, and usually you figure your way out. Okay, so we're given this one to do. Now this question it's a little bit different because either side there's work that you can do, but I prefer working on the left hand side, so that is the side I'm going to work on. So I have my left hand side. I have picked a side. That is the first thing I say to do. Pick a side and work only with that side. So now we're going to imagine this right hand side does not exist. Okay, so you ignore the right hand side, and what you will do is you work on the left hand side until what you have is exactly what is on the right hand side. So I have my left hand side. I'm just going to state it. This is sine x plus cos x. This is squared. Now the first thing I could think of to do is multiply out my brackets, and if you do that correctly, you should have sine squared x plus 2 sine x cos x plus cos squared x. This is a binomial expansion because it's two terms raised to an exponent, and just using the binomial expansion you should be able to do this. Or Pascal's triangle, you see the coefficient here is 1, 2, and 1. And remember, sine squared x just means sine x squared. So this one here, just to note, it means the same thing as this one. Okay, so this is something for you to note or to remember. So this is shorter. I think we say that this is a shorter way. This is a shorter way of writing that one, but they mean exactly the same thing. So if you see a 3 over there, it means sine x cubed. So you take sine x times sine x times sine x. So here sine squared x means sine x times sine x. Okay, so on your calculator you wouldn't press sine squared x. I think most calculators will give you an error for that. You would need to type it like this on your calculator. Okay, so back to this one. On my left hand side, this is where I started with. I noticed that I had brackets. I could use my binomial theorem knowledge to work this out, which I did. Then what I do is I see I have a sine squared and a cos squared. That is the most famous, if you will, identity. When I add sine squared x plus cos squared x, that gives me a specific number. So what I do is I just rearrange it. So I have this is sine squared x plus cos squared x plus 2 sine x cos x. So I haven't changed anything, I've just rearranged the terms. This was the first term, it's still the first term. This was the second term, it is now the third term. The third term became the second one. And like I was saying, this is a famous identity, which I'm sure you know is equal to 1. So I have 1 plus 2 sine x cos x. Okay, and then this one here, This is also an identity that you should know. That is equal to sine 2x. So what do I have here? 1, this is supposed to be an s. I hope it looks like an s. Okay, so this is 1 plus sine 2x. And if you look at that, this is my right-hand side. So the equal to signs should be there. It just looks better. This is equal to my right-hand side. And then I'm done. Some books you see QED. I think it's Latin for proved or something like that. So we're done. Some books, they draw a square like that. That also means I'm done. You asked me to show that those two are equal. I picked one side, simplified it, showed that it's equal to the other side. I am done. QED.